The James Webb Space Telescope, a highly potent instrument, continues to study intriguing celestial objects for researchers, and now on its radar, there's Pluto. We are grateful for this new wave of space observations. Scientists are making incredible discoveries, and what they've discovered about Pluto is just stunning. So, what have researchers discovered about Pluto? And how does it impact you here on Earth? Can Pluto once again be considered a planet in light of these recent discoveries? Questions are many. Stay tuned as we explore the shocking Pluto discovery. Things you need to know about Pluto. Pluto, the dwarf planet, is only around 1,400 miles wide, or approximately half as large as the United States. Although Pluto is far away, the new James Webb Space Telescope is poised to help researchers uncover more of the mysteries that lie dormant on the dwarf planet. Pluto is 5.9 billion kilometers, or 3.7 billion miles from the Sun on average. Ever wondered what would happen if you ended up on Pluto? If you were to stand on Pluto's surface at midday, you may not enjoy it. The full moon is almost 300 times as bright as the Sun, which would be 1/900th of its current brightness here on Earth. In reality, there is a period each day, close to sunset, when the light is as brilliant as midday on Pluto. On Pluto, the temperature typically ranges between -232 and -387 degrees Fahrenheit. Pluto rotates around the Sun in a 248-year orbit. For instance, Pluto was close to perihelion, the time when it is closest to the Sun, between 1979 and 1999. Pluto was closer to the Sun at this time than Neptune was. On Pluto, a day lasts around 153 hours. Its axis of rotation is 57 degrees off-center from the plane of its solar orbit. As a result, it virtually kills the side. Moons of Pluto. When Pluto was found, Bernie, 11, gave the name Pluto to her grandfather, who then transmitted the suggestion to the Lowell Observatory Institute. Pluto has 5 recognized moons: Kerberos, Charon, Nix, Hydra, and Styx. One of Pluto's moons, Charon, is almost half the size of Pluto. Its 153-hour orbit around the dwarf planet corresponds perfectly to Pluto's rotational period of one rotation. This phenomenon, referred to as tidal locking, causes you to constantly view the same side of Charon while it is at a constant distance from Pluto. These moons are not tidally locked to Pluto, which is not true of many other moons in the solar system. They all rotate and don't maintain a constant face toward Pluto. Pluto is a dwarf planet with a thin atmosphere that grows thicker as it approaches the Sun. The most noticeable plains on Pluto don't have any craters and seem to be formed of frozen nitrogen gas. This implies convection, or material blobs moving up and down. There are mountains there as well, but they are not made of rocks or soil. They are enormous chunks of water ice that occasionally have frozen gases like methane on top of them. Facts you didn't know before. Pluto offers a unique set of spectacular characteristics that have not yet been fully studied. For instance, take a look at the heart-shaped feature of Pluto's surface, known as the Tombaugh Regio informally. Its landform has a portion that resembles an ice cream cone, but that portion is completely coated in ice and carbon monoxide. The geological timescale suggests that this area may be 100 million years old. There are theories that it could still maintain its long-term form. What may have led to these? Could it be the unfavorable winds that often sweep the surface of the planet? Additionally, Pluto's dunes, just one of the planet's many surprises, are made of solid methane ice granules that are bent by the wind rather than the sand of Earth. In our solar system, dunes are more prevalent than you may think. Only Earth, Mars, Venus, Titan, Saturn's moon, and Comet 67P are home to them. As Pluto's surface had a frozen crust and these dunes remained essentially unaltered, it is most likely that they were formed within the last 500,000 years, or maybe even less recently. In this approach, Pluto raises an age-old conundrum. Pluto was originally believed by astronomers to be an ocean of frozen seeds that gradually evolved over millions of years when radioactive decay dissolved the dwarf planet's ice. For hints about its origin, they sifted through photographs of Pluto acquired by the New Horizon mission. The researchers used several computer models to examine the many ways the planet may have formed as a hot entity. Pluto might have produced heat in the early stages in one of two ways. Either the dwarf planet was warmed by energy from radioactive decay, or it was pounded by neighbouring material and the energy from these impacts would have sparked melting. The second option they found was more probable. Pluto, a planet or not a planet? Pluto had this status for many years before the International Astronomical Union modified the definition of a planet by establishing specific prerequisites. Unfortunately, Pluto fell short of all of these new standards, necessitating a global revision of geography textbooks. What, then, qualifies a planet as such? According to the IAU, a planet must circle the Sun, have enough mass to reach hydrostatic equilibrium, or a roughly spherical form, and have a defined orbital neighbourhood. The issue was that final one. Pluto hasn't been able to become gravitationally dominant or rid its vicinity of other objects. Other corpses that are around the same size as it have not been able to leave. Pluto was designated a dwarf planet, and the number of planets was reduced from 9 to 8. A rough area of Pluto was discovered via a recent picture analysis. Nothing else in our solar system or the surrounding universe compares to this. There are a few oddly abnormal ice volcanoes in the Lumby area. These features are unlike any ice or rocky volcanoes in the solar system in terms of appearance. Can there be life form of any kind on Pluto? Pluto's surface is so cold that even water freezes solid, making it impossible for life to exist there due to severe circumstances. Methane, nitrogen gas, and carbon monoxide are a few more liquids and gases that also freeze solid. Pluto's atmosphere has a pressure that is around 1 million times lower than that of Earth. This does not mean that there is no chance of discovering life on the planet. JWST's study list for Pluto. Did you know that the dwarf planet rotates counter to the big planets in our solar system by rotating backward from east to west? There is a wealth of knowledge about the planet that has yet to be found. The only project focused only on studying Pluto, its moons, and any potential extrasolar planets in the Kuiper Belt is NASA's New Horizons mission. We don't know much about the planet, so we don't know if the probe will make it through the hostile environment outside of Pluto's orbit. The fact that the satellite already has 5 moons hasn't done much to allay concerns that the spacecraft may crash with debris or yet to be found moons and eventually be crushed beneath their weight. For the time being, we expect to see more detailed pictures of Pluto as we hope to gain a greater understanding of the life that exists there. For many years, scientists thought that the rocky core of Pluto lacked the internal energy needed to ignite volcanoes. They thought that the region would have needed numerous eruptions to develop. Furthermore, the absence of impact craters in the region of Pluto's surface suggests that the ice volcanoes were active just recently and that Pluto's core retains a more residual heat than anticipated, suggesting that our knowledge of planetary systems is insufficient. Who knows?